So again, with our objective 6.3, solving systems of nonlinear equations by graphing or substitution. Again, we're looking at our system here, and we can see that we have a radical along with a cubic. And this would be pretty difficult to solve algebraically by substitution. So we want to look at this graphically. So again, for graphically, we could talk about the transformations of the functions and applying them by hand, but we also have technology that we could use to help us. So we think about our radical function and our cubic. We have an idea the radical typically starts at 0, 0 and increases. So we're moving it to the left 1 unit and it's 3 times faster than it was before. So it's going to look something like this. And then cubic functions, we know what they look like starting in quadrant 3, typically turning and going into quadrant 1, 5 times faster than it was before. We have a y-intercept here at 0, -5, pulling on things that we've talked about previous in the year. We could use the graphing calculator, like we said, by putting each function into the y-equals. We could put this into y1 and this into y2. And have the calculator do a lot of the work for us. So again, if we enter those functions into y1 and y2 on our calculator, the next thing we want to do is adjust the window so we can see what's going on. And so you can look at the table of values by hitting second graph and doing that. You can estimate based on what's going on. We have an idea of what that radical function looks like. So I'm just going to go from negative to 20 for x and y's counting by 2's. And I can always adjust from there. Again, when we're solving a systems of equations graphically, we're trying to see where those equations are equivalent at the same place, same time. Therefore, we want to see intersections. And so using that window and I'm pressing graph, I can see my two functions. Here's my radical and here's my cubic. And I can see that they're intersecting at this location here. So in order to find that location, the intersection point, we can tell the calculator to do that for us. So again, the keystrokes that we'd have to use are second, trace. We're going to pick option 5, intersect. It will say first curve and a question mark. Just move your cursor using the left and right arrows close to where it appears that it's crossing and press enter to register that location. It'll ask you for the second curve. Press enter again to register that location. And then it will say, do you want to guess? We don't. Press enter a third time, and the calculator will figure out where exactly those two functions are meeting. So at the end of this process, at the bottom of our screen, we should say intersection x equals y equals. And so this is where they're saying would be a solution to our system. So again, we said rounding to nearest hundredth. Looks like our x-coordinate would be about 0.96 and our y-coordinate would be 4.20. So it appears that we have a solution at this location. Again, to verify that it's valid, we could take our x value and y value and put it back into both of the equations and make sure that they are balanced, just like we've done in all of the previous examples.